Okay, in the yesterday class, we have seen the KNN regression algorithm. So in this, there is a one thing is important, that is called future scaling. So when you are dealing with the KNN algorithm, like KNN classification or a KNN regression, so this future scaling is very important. Okay, first of all, what is the meaning of future? What is the meaning of future? Nothing but the columns in the table. So what is the meaning of scaling? I will take example, then I will explain what is the meaning of scaling. Okay, now if you want to implement the future scaling, so you have to use the one function called standard scalar function. So using this function, you have to implement the this future scaling. Okay, so this is the function or a package you have to import. From where we have to import, already we have seen. So from the, this is the main package. Okay, this is the main package. This is the sub package. Okay, this is one sub package. It means we have to import the standard scalar function from the pre-processing package. Okay, that is what you have to import. Okay, now what is this? This is called a variable. Okay, you take whatever variable you want, you take. Now you see here, what is the meaning here? So see, I am taking a one more variable, that is x train scaled. Okay, I have taken the one more variable x train scaled. Where it is? So for this, I am applying the this standard scalar function I am applying. Okay, so again what, I have taken the one more new variable, that is x test scaled. Okay, for what I am applying? So for the x test I am applying the this standard scalar function. That is what. Okay, so this entire thing is now stored in the scalar variable. Now what I am doing? So this function, okay, this function I am applying to the x train. How to apply? Simply you have to go for the fit and transform. So when you run this code, okay, when you run this main instruction or code, so the values in the x train automatically scaled into standard scalar. Okay, that is called scaled feature scaling. Okay, I will take example, no problem. So same, whatever the fit transform we have done for the x train, same we have to do for the x test. It means whatever the transformation you have done for the x train values in the table, so same the transformation you have to apply for the x test. Okay, so this is called future scaling. Now I will take example. So what is the, so how it is going to done and what is the use of that. Okay, now you see here, for example, this is our main training data. Okay, in the x train, so I am applying the future scaling, that is standard scalar function for only x train. Same you may apply for the x test also. Okay, so these are the values. Okay, these are the values in the x train. First of all, what is x train? It is the independent variable. In this, what we are having, I am having the some values 8, 2, 4, 3, 6. They are the number of hours studied by the so and so person. Okay, that is what. Now, how to compute the that standard scalar array? How to compute the that feature scaling? Now, first of all, compute the mean and standard deviation. So, what is the mean of this? So, you know the mean formula. Okay, sum of all the values by number of numbers. Okay, number of entities, that is what 4.6 I got. So again what you have to apply the standard deviation formula. Okay, you know the standard deviation formula, then I will get the approximately 2.3 value. So this is step one. Next one, what you have to apply the standard scalar formula. So what is the formula? Scaled value equal to original value minus mean by standard deviation. This is the formula you have to apply. So when you apply the formula, okay, when you apply the formula, that is 8 is my original value minus 4.6 by 2.3, then you will get these scaled values plus 1.40 minus 1.29 minus 0.22 minus 0.75, like this I am getting. Okay, so that's what I have shown in the Google Colab. Okay, so by observation, if you go back, so these values I got in the Google Colab when I apply the standard scalar function for the x train values. That is, these are the values. Okay, so how I got, this is the formula. Okay, this is the formula how I got. Okay, so how to get the values for the extreme scale array, how to apply the future scaling. This is the formula. What is the formula? Scaled value equal to original value. So these are the original values, okay, minus mean by the standard deviation. Okay, so this is how to get the values. Now what is the use of the standard scaler? What is the use of the future scaling? Now you come down here. So first of all, okay, so what is this means? So when you get a value, so it gives the average study hours 4.6 hours. It means if a person read for 8 hours, okay, if a person read 8 hours, 2 hours, 4, 3, 6, okay, it means what is the average? So 0 means, okay, so this is 0 here. 0 means it is 4.6 approximately hours. So what is the positive values? Like 1.40, 0.86. What is the meaning of that? So the study hours are above the average hours. Negative means it is below the average hours. That is what here, this is what indication. Okay, it means it is converting the number of our the original values into scaled values. Into scaled values. What are these all those things? Plus 1.40 minus 1.29. So what is the meaning of this? For example, if it is minus 0.75, it means it is below the 4.6. That is what meaning. Okay, so that is what negative. It is below average study hours. What is the below average? It is minus, below 4.6. That is what meaning. Okay, now what is the use of this? So when you are using the KNN regression or a KNN classification, you have to go for the future scaling. It means the distances using these fair scaled balanced numbers. Okay, now I will take one example here. For example, see the some statement. Standard scalar converts the raw values. What is the raw values? These raw values into distance friendly. Okay, so distance friendly numbers showing for how far each value is from the average in standard deviation units. Okay, now take example. It is very easy. Why? We have to apply the future scaling. Now here this is the problem. I am having two types of fruits. One is apples and then oranges. Now you see here, fruit A, weight equal to 500 grams, cost equal to $2. Fruit B, weight equal to 15 grams, cost equal to $2. Fruit C, weight equal to 500 grams, cost equal to $10. So by observation, what you say? Oh, A and B are the apples, C is the orange. Okay, that is what we make some observation. Okay, that is what, okay, we are a humans, we are able to guess. Okay, now, so that is what fruit A and B are almost identical, very small, 10 grams, cost is same. Okay, by observation, A and B are, they may be apples, they may be orange. For example, if A and B apples, what is C? C is the orange. If A and B oranges, what is the C? C may be apple. That is what we may guess. But coming to the KNN regression or a KNN classifier, for example, if you take between A and B, so what is the difference? See, the computer takes, it may takes weight parameter, it may takes cost parameter. Okay, it may take any one. So then what is the A and B difference equal to? It is 10 in weight. So if you compare A and C, what is the cost? It is price equal to 8. Okay, price equal to 8. Okay, see, the system is comparing A and B and then A and C. What we have compared? We have compared A and B in terms of I mean cost. Okay, it is 2 minus 2, it is 0. Okay, so what we compare? When you take fruit C, 10 minus 2, it is 8. According to us, A and B are same. Why? Because it is getting a 0 cost. Okay, when you take A and C, the cost equal to 8. So what we say, okay, A and B are same, C is different. That we understand. But coming into the system understands like that, A and B having a value, it is 510 minus 500, it is 10. So A and C equal to, it is 8. The system thinks that 8 is a small value. Okay, so 8 is a small value. Then what it says? Okay, A and C are similar, which is wrong. Okay, which is wrong. Okay, so because A and C are different actually. Okay, but what system is thinking? So because the number 8 is small, they are very near, they are very closer. Okay, because distance is very small, according to system I am saying, A and B distance equal to what? It is 10. So when you take A and C, distance equal to what? It is 8. Okay, the distance is very near A and C. Then what the system thinks A and C are similar, which is wrong. Okay, so to overcome that, we are going for the future scaling. So the computer is thinking 8 is smaller than 10. It says fruit A and C are most similar, which is wrong. Okay. So then what we are doing? So we are converting these these raw values into some future scaling. Okay. In this way we are converting. Okay. Here also same. The number of hours are converting into some scaled values. Okay. Why? To avoid the confusion like this. Okay, to avoid the confusion like this, that is what it says. See, this is wrong. Okay, this is wrong. The computer got confused because weight uses big numbers and price is a teeny numbers. Okay, see, the big numbers are bullying the small numbers and taking over the whole calculation. That is what the problem. So to overcome that, we are going for the future scaling. So when we have to apply, when you are using the KNN regression or a KNN classifier, you have to use that future scaling. How to implement future scaling? You have to use the standard scalar function. So then, yeah, you were able to overcome this type of problem, this type of some wrong classification. See, that is what A and B are similar according to us, but what system thinking A and C are similar, which is wrong concept. So for that we have to apply the future scaling using the standard scalar function. Okay.